Welcome to today's deep dive. So I want you to imagine an employee who can, process 10,000 delayed orders in 3 minutes.
Sounds like a dream hire.
Right. I mean, they write perfect integration code on the fly, they never sleep, but there's a pretty massive catch.
There always is.
Yeah. Imagine that same employee has total amnesia regarding your company's security policy. And on top of that, they have full, unsupervised access to your corporate bank account.
Yeah, that is terrifying.
It is. But that is exactly the reality of enterprise AI right now. Our mission today is to look at a stack of sources about the bleeding edge of AI automation, specifically a system called Safebox, to understand how to fix this.
And it is a fix that is desperately needed.
Because everyone is hearing the same story right now, right?
Yeah.
Building AI workflows is as easy as, dragging and dropping or typing a sentence into a chat box.
Which is technically true, but...
But here's the elephant in the room. If it is so easy, why aren't hospitals or banks or government agencies actually using it for their core operations?
Yeah.
It's basically like handing the keys to a Ferrari to a 12-year-old. I mean, sure, it's incredibly fast and easy to start the engine, but you have absolutely zero control over the resulting chaos once it actually pulls out of the driveway.
Right, and if we connect this to the bigger picture, the tools that most people are using right now, like Zapier or Make, they were designed entirely for speed of connection.
Right. Make it work quickly.
Exactly. They were not designed for depth of governance. So if you are a highly regulated organization, you simply cannot trust an AI that operates on, best efforts or good intentions. Safebox is essentially the architectural fix to this whole control problem.
So how does it actually do that? How do we move from those good intentions to structurally enforced safety?
Well, it starts with a fundamental shift in the mental model. The core principle of Safebox is this: AI can propose. Only policy can execute.
So the AI is stripped of its autonomy.
Completely. The AI is entirely read-only. It can look things up, sure, but it cannot write to a database. It cannot send emails. It cannot trigger payments.
Okay, let's unpack this. If it can't do any of those things, what does it actually do?
It just puts a structured proposal into a queue. It basically says, hey, based on my analysis, I would like to trigger this specific script. But it cannot pull the trigger itself.
Interesting. So what prevents it from just quietly pulling the trigger anyway? Like, what if the AI goes rogue or hallucinates a command?
That brings us to the first of their 5 pillars of safety. No action without permission. Every single piece of automation code must be cryptographically signed by designated human overseers.
Oh, wait. That sounds a lot like the mechanics of a smart contract on a blockchain.
It is a very similar concept, yeah. It's like a multi-witness contract.
So instead of authorizing a financial transaction, you're authorizing an API call.
Spot on. And that signature is tied to the exact hash of the code. If an AI or even a human hacker alters one single character of that script later, the cryptographic signature breaks.
Wow. So it just won't run.
It physically cannot run. It's not just a compliance warning popping up on a dashboard. It becomes mathematically impossible for the system to execute the action.
Okay, that makes sense for the code itself. But what about the keys to the kingdom? Like, every integration needs an API key or a password.
Right, the credentials.
Yeah. In most places, those just live in a config file somewhere. If the cloud provider gets hacked, those plain text keys are just sitting there.
Which is exactly why Safebox uses unhackable credentials. In this architecture, your keys are encrypted directly inside your browser.
Before they even leave my laptop.
Exactly. They travel to the cloud provider's servers as unreadable blobs of data.
But wait, if they are unreadable blobs on the server, how does the automation actually use the key to, say, log into Shopify?
That is where hardware-verified memory comes in. The unreadable blob is decrypted inside an isolated physical chip on the server. It's often called a secure enclave.
Oh, okay.
Yeah.
Like a digital vault inside the microchip.
Perfect analogy. The secret is decrypted in that vault, used for the exact fraction of a second needed to make the API call, and then it is instantly wiped from memory.
That's wild.
And it goes even further with tamper-proof infrastructure. When the servers boot up, the hardware actually measures the software image against a known audited hash.
So if a hacker changed a single byte of the server software,
The hardware refuses to release the decryption keys for the hard drive. The server simply stays encrypted. It won't even start.
Okay, I have to push back here for a second.
Yeah.
Because isn't the whole point of AI to be fast and autonomous? If I have to cryptographically sign every single action and use hardware enclaves, Haven't we just created the most bureaucratic, sluggish AI in the world? I mean, it really sounds like putting a heavy governor on that Ferrari.
I get that. But what's fascinating here is that the goal isn't to slow down the execution of tasks. The goal is to guarantee compliance upfront.
So the friction is front-loaded.
Exactly. For legal and risk teams at a major enterprise, clearing that security bar isn't just a nice-to-have luxury. It is a strict, non-negotiable requirement for going into production. If you don't have those structural guarantees, you just don't get to use the AI.
Okay, so you pay an upfront tax and complexity so that you can run at machine speed safely later.
Precisely.
Let's shift gears then. Let's look at how this actually feels for the everyday user. Because dealing with cryptographic hashes sounds like an absolute nightmare if I just want to automate some emails.
It would be, yeah. But the end user never sees the cryptography. The sources describe Safebox as an opinionated system.
Opinionated system. What does that mean in this context?
Think about Shopify or Stripe. You don't build a payment gateway from scratch anymore. You deploy a proven, pre-built pattern. Safebox is the same way. You aren't building complex workflows from scratch. You are deploying proven patterns.
Let's use a concrete example from the sources. We have Rachel, right? She's an ops manager.
Yes, Rachel. She wants to automatically email customers whose orders are delayed by more than 24 hours.
Normally, she'd have to submit an IT ticket and wait 3 weeks. But here, she just opens a chat interface and talks to the Safebox assistant in plain English.
Right. And the system immediately starts looking through its library of tools. It finds the tool to check shipment status, and it finds the tool to send customer emails.
But then it realizes it doesn't have a specific connection to their custom Shopify setup.
Exactly. And in a traditional system, you'd be stuck right there. You'd have to wait for a developer.
But the research says the AI just reads Shopify's documentation, automatically generates the code, runs it through a reviewer, and wires it up. In minutes.
It does. It composes the workflow dynamically.
Wait. So the AI is just writing its own integration code on the fly.
It is.
If I'm an IP director, that gives me hives. What if it hallucinates a command and accidentally deletes the company's entire active storefront? Doesn't that completely contradict the whole architecture of trust angle?
It would, if it were pushing directly to production. But remember our core rule. AI can propose, but only policy executes.
Ah, right. So it can't just run the code it writes.
Exactly. It's forced to execute that generated code in an isolated testing sandbox that just mocks the API calls. And the system runs automated security policies against it.
So if it tries to write or delete data when it should only be reading?
The sandbox fails it immediately. And if it fails this automated check 5 consecutive times, it hits a hard start.
Oh, so it doesn't just loop forever trying to guess the right code.
Nope. It packages up the documentation it read, the code it tried, and the errors it got, and routes it to a human engineer. The engineer fixes it once, signs it, and now it's permanently available.
Okay, so the AI is never allowed to deploy broken code. That makes sense. Let's follow Rachel's workflow because what happens next is really the magic of the whole system.
The shrinking approval loop.
Yes, so Rachel is cautious, right? She sets up the workflow and tells the system, cap the emails at 200 per run. I want to keep an eye on things.
A very normal human reaction to a new tool.
Totally. So Tuesday rolls around and the workflow actually finds 214 delayed orders. What happens?
The system pauses. It hits that policy constraint of 200, so it stops and asks for permission.
And it sends Rachel a notification on her phone, right?
Yeah, it says, I have 214 delayed orders. Here is a sample. Do you approve this batch? And the amazing thing is, Rachel can approve this via a voice command and a biometric scan on her phone while she's literally driving to work.
Because it's using the hardware security enclave on her phone to decrypt the signature.
Exactly. The action is fully secure, but completely frictionless for her.
So she approves the 214 emails.
Yeah.
But then the system asks her a really important question.
It asks, do you want to turn this into a permanent rule?
Yes. And here's where it gets really interesting. She says yes and sets a rule to auto-approve batches under 500.
It is a massive aha moment. Because in most companies, governance is a permanent tax on action.
Right. If you need a manager's signature today, you'll need it every Tuesday for the rest of your life.
But here, the governance is a temporary overhead. The moment Rachel hits yes, her preference is encoded into a permanent mathematical rule.
It's just like training a new employee. You know, you micromanage them for the first week, checking all their work. And once you trust their judgment on specific tasks, you let them run with it.
But you're letting them run within strict, mathematically defined company guardrails. And because of that, the approval queue naturally shrinks over time as the organization's preferences are encoded.
It's brilliant. But I want to pivot to a massive real-world problem for companies using automation, and that is getting banned on platforms like LinkedIn or WhatsApp or Twitter.
Ah, yes. The dreaded ban hammer.
Right. Because if Safebox is sending messages on someone's behalf, how does it avoid getting flagged as a bot? I mean, platforms are cracking down hard on this.
This raises an important question about how we authenticate. Most automation tools treat a personal social media account the same way they treat a corporate database. They hold the login credentials on a central server and just hammer the platform's API at machine speed.
Which is exactly what algorithms look for to ban you.
Right. Safebox solves this through a dual architecture. It structurally separates organizational authority from personal action.
Okay, break that down for me. Organizational versus personal.
So the organizational path is for official company actions. The branded customer support bot, the official company email, those run on the verified cloud servers we talked about using official company credentials.
Okay, that makes sense for the corporate stuff.
But personal action is different. If a workflow needs Sarah from the sales team to send a LinkedIn message, it cannot operate from a central server. It routes that instruction down to Sarah's own web browser through an extension.
Oh, wow, so it runs locally on her machine.
Exactly.
Yeah.
It uses her authentic, logged-in session, and it interacts with the interface at a staggered human pace. It literally moves the mouse and types for her.
Okay, so Safebox isn't impersonating Sarah from a server somewhere. It's just assisting her locally. But wait, isn't there a huge risk there? What stops the company from hijacking Sarah's personal LinkedIn and, spamming her entire network while she's away from her desk?
That is where the structural policies come back in. The architecture physically prevents official mass communications from crossing into the personal paths.
So a mass marketing workflow literally cannot route to a personal browser extension.
It physically cannot. The system separates the domains so strictly that hijacking an employee's personal session is an impossible edge case by design.
Wow. Okay, so we have this incredibly secure, decentralized, but governed system. Let's look at the long-term game here. Once a company, say a big hospital, gets inside this ecosystem and sets up their policies, why would they ever leave?
They wouldn't because of the compounding value. The network effects here are incredible. Every time a new tool or workflow or plain English policy is created and audited, it gets tagged and stored in a library.
So the second time someone in a different department needs that exact same workflow.
It costs almost nothing. The friction is completely gone because it's already been cryptographically signed and approved.
And the sources mentioned that this actually extends beyond just one company, right?
Yeah.
There are financial incentives to share.
Yes, there's a whole monetization layer built in. If your organization architects a really reliable workflow and shares it to the broader platform, you earn a small credit every single time another organization uses it.
Wait, really? You get paid for your automation templates?
You do, and it applies to external data too. Say your workflow needs to fetch a pricey market analysis from a third-party vendor. You pay for that data pull.
Right.
But Safebox caches that encrypted result. If another organization on the network requests that same data an hour later, the platform delivers the cached version. They get it cheaper, and your organization gets a commission for funding the initial pull.
So what does this all mean? The network effect isn't just more users makes the app more fun. It means there is a massive, constantly growing library of cryptographically audited business tools.
Exactly. And counterintuitively, as the library expands and gets more complex, the governance actually gets stronger. You have more audited paths to rely on.
This has been an incredible journey.
Yeah.
We moved from a world where enterprise AI is this chaotic, untrustworthy intern with the keys to the Ferrari, to a world where AI is tightly constrained by mathematical certainty.
It is a profound shift. Safebox isn't just a slightly better automation tool. It is the missing bridge that serious organizations need to finally use AI safely in production.
And I want to leave you with a final thought to mull over. We've spent this whole time talking about how a single organization builds a library of trust.
Right.
But think about what happens when an entire industry, say healthcare or global finance, starts sharing a single standardized library of these cryptographically signed compliance policies.
Right.
Could we reach a point where regulatory compliance is no longer a massive department of human beings auditing paperwork?
That is a fascinating idea.
What if compliance just becomes a shared open-source network of mathematical rules? A proactive law of physics built into the software itself. It completely redefines what it means to be a secure enterprise. Keep that in mind the next time someone tries to sell you an autonomous AI agent. Thanks for joining us. We'll catch you next time.